epidemic season, which just ended, we had 53% of isolates of pandemic virus, very few of H3N2 virus, though a rather big proportion of B virus, about 45%. These are the data of our laboratory. And as an example of surveillance of influenza, in Russia I showed you, I have chosen one season and showed you the regional distribution of viruses. Let's see first, this is Astrakhan, this is the south of Russia. Here is the picture of morbidity and epidemic thresholds. So we had epidemic events here. The excess of morbidity are above the epidemic thresholds. The isolation of viruses showed that there were a big proportion of H1N1 virus, rather big proportion of H3N2 and some B viruses. And here is immunofluorescent diagnostic of not only influenza viruses, of parainfluenza, adeno, and RS viruses, respiratory syncytial viruses. So the other region, extreme west of Russia, Kaliningrad. Here the picture is different. The only one episode of epidemic, but more essential excess of epidemic thresholds. And here we see no H3N2 viruses. Only H1N1 and B viruses were isolated. So the picture was different. And finally, in the extreme east of Russia, Khabarovsk, here we see practically no epidemic. The epidemic threshold was not exceeded, and mostly of isolates were H3N2 viruses, with very few H1N1 viruses. So you see, as well as Russia has a very big territory, there are regional differences even in one epidemic season in different parts of this country. Determination of susceptibility of isolated strains to antivirals is also an important direction of our work, and the isolates are regularly analyzed for rimantadine and oseltamivir susceptibility, both by decrease of virus reproduction, so phenotypically, and in the way of sequencing of M2 protein to reveal the mutation or two mutations that lead to resistance to rimantadine and other adamantans, and neuraminidase gene sequencing, which shows possible mutation of resistance to oseltamivir. Here is a picture of the same season, which I just shown you. The study of susceptibility to rimantadine by hemagglutination, by ELISA test, by sequencing. So there are resistant, R and S sensitive. So you see that there are from time to time some contradictions. The sequencing shows us that the virus is sensitive, but phenotypically it is resistant. Very interesting. And there are the different, when, for example, by hemagglutination virus is resistant, but and sensitive by sequencing. So one should combine all this method to have a conclusion on the resistance. Here is the picture of sequencing of part of neuraminidase, Russian isolates. In bold here shown the reference strains, international reference strains. There is a mutation in this position 275 of neuraminidase, the changing of histidine to tyrosine in neuraminidase protein, and epidemic season, 44% of Russian isolates were resistant to the isotretinoin, the H1N1 isolates. But this was before the pandemic. The pandemic viruses are nearly all sensitive to isotretinoin. Now, a little bit about pandemics. We had in 20th century 3 main pandemics. The most disastrous was Spanish flu, 1918, and by estimation there was from 20 to 80 million deaths, human deaths. Then it was provoked by H1N1 virus. Then it was in 1957 Asian flu, H2N2, and estimated to 1 to 3 million deaths. And Hong Kong, epidemics of Hong Kong flu, H3N2, the number of casualties was more moderate. So, at the last years from 1997, we were all alarmed by possible pandemic of avian origin, of avian influenza H5N1. And this was supposed to be a next pandemic agent. Here are the properties of this virus. Since 1997, the first outbreak in Hong Kong, this virus has acquired a number of unusual characteristics. High pathogenicity to humans. Lethality is more than 50%. You imagine that it is a very dangerous disease if you are infected. Capacity to infect humans directly from birds without an intermediate host like swine. Resistance to interferon. Ability to provoke a hyperproduction of pro-inflammatory cytokines accompanied by the development of acute respiratory distress syndrome, so-called cytokine storm, hyperproduction of pro-inflammatory cytokines. The capacity to provoke multi-organ injuries, including brain, liver, kidney, and other systems. But so far, I last have figures from 3rd June of this year. We have 555 laboratory-confirmed cases of H5N1 influenza in humans, and of them, 58% lethal cases. So it is not very, the contamination luckily does not proceed from human to human, but if you are infected, the lethality is very high. And in Russia we had only episodes. There were no, luckily, human cases. Since this virus appeared. The first major outbreak was in July of 2005. It was the south of Siberia, and the virus migrated according to the pathways of migratory birds, like ducks, geese, and other migratory birds, from China, western China, through Kazakhstan, and the other branch through Mongolia. And 6 regions were touched with these epizootics, with a disastrous effect to poultry industry. You see that about 13,000 birds died of avian flu, and more than 100,000 have been killed in the containment efforts. The factories producing broilers were cleaned, and all the chicken were destroyed. But luckily there were no human cases. Then it was a little bit repetition of this, even in winter, in January of 2006. From this region, virus spread to the south of Russia and contaminated 11 regions in the south of Russia. And again, it were big losses in the wild birds as well as in domestic poultry, but no human cases still. Since then, there were only minor outbreaks in 2007 in Far East and near Moscow, but very little. And then the last 4 years were more or less calm in this respect. And our institute have got several samples from South Siberia, and we sequenced several strains, completely sequenced all the genomic strains, and all the strains were similar to progenitor influenza bar-headed goose of Qinghai. This is the West China, the province of Qinghai, and Whoopers swan in Mongolia. Here is the phylogenetic tree, and Russian isolates sequenced in our institute are shown in red. These are 2 prototypes, and these are the isolates from South Russia, and these are from Crimea Peninsula in Ukraine. All they are attributed to clade 2, subclade 2 of highly pathogenic avian influenza. Here are this card. So we prepared all last years to avian highly pathogenic influenza, which supposed to come from Southeast Asia. But although 2009 pandemic was swine not avian origin. It came from North America, not Southeast. Not as highly pathogenic as expected. So, influenza pandemic 2009, which started in Mexico and in California, as you know probably, on March and April of 2009. And the origin of this virus is very interesting. It is so-called triple reassorted virus, which combines genes of at least 4 different origins. 2 genes of polymerase complex, PD2 and PA, are from birds, here in brown. 1 gene, PD1, of polymerase, came from human, from H3 and 2 strain. 3 genes, hemagglutinin, MP protein, and NS protein, are from classical or North American swine lineage of influenza, these 3 segments. And another 2 segments, neuraminidase and N protein, are from Eurasian swine, here. So, many people, especially in journalist medium, propose that this virus has some artificial origin because, for example, these genes from so far regions, from North America and Eurasia, cannot combine naturally. But later on, it was proven that all these are no more than speculation. That this strain has very natural origin, and the strains like this were already discovered in the United States for at least 3 years before this pandemic, but they did not provoke any outbreaks, only isolated patients suffered.